Let's calculate the pH of bases. Now, unlike acids, where when they dissociate, they directly make H plus, and then we can just take the negative log of that to get the pH. If we did the same thing with bases, we would get POH. And that's not what we're asking. That's not what we're looking for. We're looking for pH. And so we will need to convert the hydroxide concentration into H plus concentration. Now, one way to do this is to use the Kw expression, which I've written out here. This is from the auto-ionization of water. We have H3O plus times OH minus equals Kw. And if you recall, Kw is 1 times 10 to the minus 14. So, if we want to convert in between hydroxide concentration and pH, we can do that simply by moving the hydroxide concentration over here, and we'll get H plus concentration, which would look like this. So if we just take 1 times 10 to the minus 14 divided by the hydroxide ion concentration, that will give us the H plus concentration. And then if we want, we can take the negative log of this number and get the pH. There's another way to do this, though, that involves less exponent manipulation, and it will have less chance of error, I believe. It's also the minimum number of keystrokes that you can put into a calculator to take the concentration of OH minus and turn it into the pH. And I'll show you how I got this formula. If you recall, pH plus POH equals 14. And you can get this just by taking the negative log of this equation right up here. When you do that, you'll have negative log of H3O plus, negative log of OH minus, and negative log of 1 times 10 to the minus 14, which is just 14. And you'll end up with pH plus POH equals 14. Now, let's start manipulating this just a little bit. Let's move this POH over to the other side to isolate pH. So if we do that, we have pH equals 14 minus POH. Now, let's expand what POH actually is just a little bit. So now we get pH equals 14 minus negative log of the hydroxide ion concentration. This is just the definition of POH. And you'll notice that if I have a minus and then another minus sign, that's the same as if it was a plus sign right here. So I'm just going to change this into a plus. So I think the fastest way to go from a hydroxide ion concentration to a pH is to put in 14 plus log of the hydroxide ion concentration. Then that will get you directly to pH. So let's do an example on this. Let's say I have some sodium hydroxide. I'll write it over here. No, I'll write it down here. This is a base. It's a strong base. And so just like our HCl example, this will completely ionize in solution. So if I choose 0.02 molar of NaOH, what would be the pH of this solution? Well, I can choose this, take this, put it in my formula that I just made up here, and calculate the pH. So I'll just say 14 plus log of 0.02 equals some number. I'll get that for you real quick. And I get 12.3. So that is how to calculate the pH of bases. Now, if we have a weak base, we will have to go through and calculate the using an ICE table. And I'll make the next video focus on that because there's a little bit more to it.